Hi, welcome to Maths with Shai MA. I am Shai MA. Please like, share, and subscribe. Let's get to today's lesson. For this module, we'll be looking at the quadratic number pattern. The quadratic number patterns. Now, why do we say this is quadratic? Because it is from the quadratic formula, where we have the formula for quadratic. It's f at x equals to ax squared plus bx plus c. So this is a quadratic function. So we say this is quadratic number pattern because it has ax squared plus bx plus c. It's in this form. So now, because now we are looking at a number pattern, we will write it in terms of Tn for a quadratic pattern. So it will be a, where there was x, we'll put an n. So it's a n squared plus bn plus c. So hence we are saying the quadratic number pattern. Now, how do we know that this is a quadratic number pattern? Let's take, for an example, let's look at this pattern: 2, 6, 16, and 32. Now, if we check the difference, the first difference, 6 minus 2, remember, you must always take the 1 from the left and subtract the 1 from the right, subtract the 1 from the left. So in other words, this time it will be 6 minus 2, which is a 4. And in this case will be 16 minus 6, which is a 10. And then the 32 minus 16 is a 16. So when we look at this, there's nothing common here. So hence we move on. We do the difference again, the right minus the left. So the 10 minus the 4 is a 6, and the 16 minus the 10 is a 6. Now we see something common. So because it is a common difference, we call it a quadratic number pattern. It's going to give us this type of a pattern. So now that we know there's a common difference, second common difference, we are able to use this to get a and b and c. So to get the value of a, this a here, we say 2a equals to the second common difference, whatever the second common difference that you would have found. So 2a remains always, it's always 2a because it's the second common difference. So 2a equals to, in this case, our second common difference, it's 6. So we say 2a equals to 6. And then we divide out, we get the value of a, which is a 3 in this case. So now we want the b and the c. So after a, we can choose whether we want to start with b or to start with c. So we are going to take a look at both. Now, the common way is to start with a b. Now, let's look at our quadratic equation. We are going to look at term number 1. Remember, term n is an squared plus bn plus c. So term number 1, in other words, where we see n, we put a 1. So we substitute. So it's going to be a into 1 squared plus b into 1 plus c. So which is giving us a 1 squared is a 1 times a is a plus a b plus a c. So that is term number 1. It's a plus b plus c. Okay, let's do the same thing to get term number 2. So in other words, now on our quadratic equation, where we see n, we now put 2. So it's a into 2 squared plus b times 2 plus c. So 2 squared is a 4 times a is 4a plus 2 times b is 2b plus c. I think it's enough to have both term 1 and term 2. Now, we are going to subtract term 1 from term 2. So in other words, we are taking term 2 and subtract term 1. So in other words, we're taking this and subtracting this. So 4a minus a is 3a, and then 2b minus b, it's b, and c minus c is 0. So in other words, term 2 minus term 1 will give us 3a plus b. So this, we're going to take this formula here and substitute the things that we know. We already know what is a. We already know what is term 1, which is 2. A is 3. We can even substitute term 2 minus term 1, which we said is a 4. Or we can substitute straightforward. So let's substitute. Term 2 minus term 1, we said it's a 4. And then a, we calculated a, we said it's a 3. So we substitute a with a 3. And we have the value of b, which is unknown. Now multiplying this, we have a 9 plus b. So if we take the 9 that side, it will be minus. And so we have a b. So 4 minus 9 is negative 5. So this is giving us our b to be negative 5. So b is negative 5. Now we have a to be 3. We have b to be negative 5. We want c. So we can either substitute in either of these equations that has that has c. So the simple one is equation number 1. So which states that term number 1 is a plus b plus c. So we substitute everything so that we can get the value of c. So term number 1 is a 2. It's a 2. Term number 1 is a 2. Okay, so let's substitute. Term number 1 is a 2. And then a, we have calculated a. We said that the value of a is 3. So we say is 3. And the value of b is just here. B we said is negative 5. So we have our negative 5. And then we substitute, we get the value of c. So let's work it out. So we have 3 minus 5, which is a negative 2, plus c. Taking c to the other side, it's going to be plus. So we will have 2 plus 2, which is our c. Therefore, our c is 4. So now we have our value of a, our value of b, and our value of c. So we substitute them on our number pattern, which we said is an squared plus bn plus c. So in other words, the general term for this number pattern, we said a is a 3, so it's 3n squared. A b is a negative 5, so we put a minus 5n, and the c, we just calculated it to be a 4. So that is our quadratic number pattern. So this is if we decide to calculate b first. So in this case, we have calculated a, we have calculated b, we have calculated c. So now I want us to look at a situation where after calculating a, we go to c before b. It is also possible. Let us go back to our the same quadratic number pattern. We have 2, 6, 16, and 32. 2, 6, 16 and 32. So already we have seen that A is 3. We have seen how to get A. We said that A is a 3. So let's see how what we did. We said, okay, the difference, we said it's 4, 10 and 16. So with this ones, we realized that we have a 6 and a 6. That's how we got our A. So we were able to get A. We said 2A is 6 and then A is 3. Now we are going to go to C. Remember, our general term is term n is an squared plus bn plus c. Now we are going to get C first. We have A, we get to C first. Now if we look at this quadratic number pattern here, if we want the next term, we keep on adding. We say 2 plus 4 is 6, and 6 plus 10 is 16, and 16 plus 16 is 32. Like that. We can continue, we can get the next term like that. So the second difference is always 6. Now, how do we get it? 32 minus 16, 32 minus 16 is 6. And how do we get this one? If we take 16 and subtract 6, we get 10. If we go back, 10 minus 6 is 4. So we want term 0. We want to know, remember, this is term number 1, this is term number 2, this is term number 3. Like that. This is term number 4. So we want a way of getting to term number 0, because term number 0 is our value of C. So we are going to now subtract. We want to go back. So we know that this must always be a 6. So if we subtract 10 minus 16 minus 6 is 10. 10 minus 6 is 4. Then what is 4 minus 6? So we know that 4 minus 6 is a negative 2. So that's our first achievement. Now we are getting this line. We got this line now, the first difference. So what we are going to do now, we are going to look at the same thing. Remember, 32 minus 16 is 16. 16 minus 10 is 6. 6 minus 4 is 2. Then 2 minus a negative 2. Remember, this is a negative, so you should not make a mistake there. You have 2 subtract a negative 2. So you need to be careful with that one so that you don't make mistakes. So this is negative and this negative, remember, is going to be positive. So you have a 2 plus 2. So in other words, right now we are able to get term 0, which is 4. So we now know, okay, term 0 is 4, and it is the same as the value of C. In other words, C is 4. So after getting C to be 4, so we can now go to our term 1. We said term 1 is A plus B plus C, and then we know what term 1 is. So let's look at term 1. Term 1 we said is 2. So we substitute term 1 to be 2. And then A, we have already found it out, is 3, remember. Now what we don't have is B, but we have a C. So we can write the B. And then we have C. We have just calculated the value of C, which is 4. So now we are going to calculate C. So we will just add this 3 and 4, it's a 7 plus B. And now taking the 7 that side, so we will have a 2 minus 7. And then we get our value of B. So in other words, B is a negative 5. So we have the A, the B, and the C. So we can substitute them on our general formula. So it's an squared plus bn plus c. So we have A, we said, is 3n squared, and then B is a minus 5n plus C, which is a 4. So if you look at this equation, that's where we started with C first. We calculated C first. So we need to remember that C is term number 0. C is term number 0. So we got C first to be 4, and then later we got a B. So if we compare this equation with this equation, you can realize that we have the same answer. So it's 3n squared minus 5n plus 4. So you need to decide which one you want to start with. Right, so now we are going to take examples. We will be looking at the past papers that we found from the grade 12 November papers, national papers. So we will be doing that. Okay, thank you. Let's start. Let's take an example from November national paper 2017. We are going to look at this example. Let's do it. Question 2, paper 1, 2017. Now we have given the quadratic number pattern 5, -4, -9, and -40. So the first question is very easy. Determine the constant second difference of the sequence. Just 2 marks. So we do as we have seen it. I'm just writing the sequence down, and then so the second difference, we said we take this term 2 and subtract term 1, and then which is -4 minus 5, it will give us -9, and -19 minus -4. So you need to understand that we are saying here -19 minus a -4. Please, we should not forget this minus here. So this is going to make it -19 plus 4, which will give us a -15. Same story applies here. It's -14 minus, 40. It's a 40 here. So it's -40, not 14, but -40 minus a -19. So this is going to be a -40 plus 19. So we need to be very careful here as we work this out, because that's where we lose marks, and then this will be -21. So that's how we get the first differences. We get the first differences that way, so we should be very careful about that one. So now we continue to get the second common difference. So the same story applies, the right minus the left. So it's -15 minus 9. So it's, as we say, -15 minus into -9. So this is going to be a plus. It's a plus 9. So -15 plus 9 it's now a negative 6. So doing the same thing here, negative 21 plus 15 is going to be a negative 6. So it means, as the question was saying, the first constant difference of the sequence is negative 6. Our constant difference is negative 6. So that was 2.1.1. So let's look at 2.1.2. This one has 4 marks. So we want to get the nth term. So that's 4 marks. So remember what we did. We said that we start with A. So we can simply say 2A is the second common difference, which in this case is negative 6. And then we divide by 2. And we get a negative 3. So we have our A, and then we can go to B. Remember we said that if we take term 2 and subtract term 1, this will give us a 3A plus B. And then term 2 minus term 1, already we have done the subtraction here. So it's a negative 9. And then 3A, we calculated it here to be a negative 3 plus B. So we are taking this, a negative 3 times negative 3 is negative 9 plus B. So when we move the B, the 9 to the other side, it's going to be plus, giving us the value of B to be 0. So B is a 0. Now, looking at what we had, we said that term number 1, it's A plus B plus C. So substituting every value that we have, term number 1, we said that the first term is a 5. So we have a 5. And then A is calculated to be 3. So not 3, a negative 3. A B was calculated to be 0. There it's just B is 0. So we can easily get a C. So we take the 3 to the other side, the negative 3 to the other side, so it will be plus. So 5 plus 3 is 8. So C value is 8. Therefore, our general term, the nth term, we know that we said it's an squared plus bn plus c. So substituting the values we have calculated above, we have the A, which we said is negative 3. The A there is negative 3 n squared, or B is 0. B is 0. So we put a 0 here. It gets rid of everything. And then plus C, C is 8. So it will be plus 8. So that is our general term. So that was 2.1.2. So that was 2.1.2. So we go to 2.1.3. Now the question is, which term of the pattern will be equals to negative 25,939? The term which is equals to negative 25,939. Wow. So this term, we call it term n because we want to know what this n is. It's a certain term number, but we know its value, which is negative 25,939. So already we know what term n is, so we will substitute it here. So which is negative 3n squared plus 8. So this is negative 25,939. Now we are going to work it out. Take the 8 to the other side. So we will have negative 3n squared equals to, so when the 8 goes that side, it will be a negative. So we add this together, and then we will get negative 25,947. So dividing this by 3, dividing this by negative 3, we will get, we divide both sides by negative 3, so this will give us n squared equals to 8,649. Right. Now the square root of n squared, we know that square root always is plus or minus, but because we are talking about terms, so they are all positive, so we should remember that. So we can take the positive square root of this number. So we find the square root of 8649 on our calculators, and then we get a 93. So in other words, this negative 25,939 is term number 93. So it is term number 93. Right, so that was November 2017. So I'm going to take another example. There it is. This one was written in November 2024. It's, wow, November 2023. Question 2, November 2023, question 2. So it's one of those nice questions that we came across. So we are given a quadratic number pattern, and we are given that term number 1 is a 3, and then what is happening here is that term number 2 minus term number 1 is 9. Therefore, what has happened here, they have subtracted term number 2, they subtracted number 1, and they got the difference to be 9. And as we continue, because it's a quadratic number pattern, we have term number 3, subtract term number 2, we got 21. So the sequence continues that way. So we have a term number 4. Right, but they gave us that this is a quadratic number pattern. So in other words, there's the same common difference. So 21 minus 9 is 12. So we therefore know that also here is 12. So all the differences will be 12 because it is the common difference. So remember, when we take this term and add this term, we get this term. So it means 3 plus 9 is 12. So giving us the second term, the second term there to be 12. And then we want term number 3, we do the same. 12 plus 21 is 33. Right, so now to get the one here, we will say 21 plus 12. 21 plus 12 is also 33. So we have the term here to be 33. So as we continue that way, 33 plus 12 is 45. So we continue, we want term number 5. We know that this is 12 here. We add the terms like that. So let's see. 33 plus 33 is 66. Right. We want term number 5. Term number 5. So we'll say 66 plus 45, which is 111. So that's what they want. So term number 5. So it means we have our sequence as 3, 12, 33, 66, and 111. So term number 5 is 111. Right. So there we got it. We have shown it that it is 111. So we need to be able to do these terms as they are, count them one by one as we go there. So let's look at number 2. Number 2, it says show that the general term of the quadratic pattern is term n is that. So we are simply going to calculate the general term here. So we know that the second difference is 12, therefore 2a equals to 12. So giving us a to be 6 as we divide by 2. And then we have our a, now we want our b. So we know that term number 2 minus term number 1 will always give us 3a plus b. So term number 2 minus term number 1, we know it's a 9, and then equals to 3a, we know it's 6. We are looking for b, so 3 times 6 is 18. 9 minus 18 is negative 9, so leaving us our b to be a negative 9. And then we can now say term 1 equals to a plus b plus c, which will help us to get a value of c. So term 1 is a 3. It's a 3. So we have a 3. A is 6. That's a is 6. B is negative 9. And C is what we are looking for. We are looking for C. Now we are taking everything to the other side. The 9, when it comes here, it will be plus. So 3 plus 9 is 12. The 6, when it comes that side, it will be minus. So 12 minus 6 is 6. So C is 6. Therefore, the general term of this pattern will be 6n squared. That's an squared. A is 6 plus bn. B is negative 9, so it's negative 9n plus c. C we said is 6, so it's plus 6. So that's answering question number 2.2.2. So we go to question number 2.2.3. Now it says that show that the pattern is increasing for all n is a natural number. Now we need to understand this question. It's one of those challenging questions. So now we need to understand that natural numbers are starting from 1. So in other words, the question is trying to say, let's prove that the pattern is increasing from 1. So meaning 1, 2, 3, 4, like that. So the pattern is increasing. It is an increasing pattern from that. Now let's remember that We said this is a quadratic number pattern, and a quadratic number pattern gives us a parabola if we draw it. So remember, with a parabola, if a is positive, then we are going to, if it's a is greater than 0, we are going to have an increasing function like this. And if a is less than 0, we are going to have a decreasing function. So our function here, a is positive. So we are looking at a function that goes that way. So it's an increasing function. Now, we want to know the minimum value, the lowest value here. And the only way to get the lowest value here is to calculate the x-coordinate of the turning point, the x value here. So most of us, we know that we can use the formula x equals to minus b over 2a, or you can use your derivative to find this coordinate there. So but let's stick with this. So it's minus a b is a negative 9, and then a is 6. So we are getting here, simplifying it, it's a 3 over 4. So meaning our minimum value is 3 over 4, the lowest value. So a number which is more than 3 over 4, and it is a natural number. Any number which is more than 3 over 4, which is a natural number, it's a 1. Therefore, our function is increasing for n, anything n is greater than 3 over 4, which is 1. So for n is greater or equals to 1, which is our first natural number, the function is increasing. That answers our question. Thank you very much. I will see you in the next lesson. Please don't forget to subscribe and like it. Thank you very much.